Today we're doing section 8.2 and it's going to be in 2 videos, so this will be part 1. Alright, our learning target for this one, we are going to graph rational functions. Okay, so if we're going to graph rational functions, we need to know what a rational function is. So let's define it. Okay, this is a function in the form f of x equals p of x over q of x, where p of x and q of x are polynomials. Okay, so another way to say this is just a fraction where a polynomial is on top in the numerator and on the bottom in the denominator. A fraction of polynomials. Okay, when we start out graphing, remember how we start with the parent function. So the very most simple rational function would look like 1 over x. Okay, now let's make a simple xy table. I'm going to pick a couple of negative values. Now I can't pick 0 because remember I can't divide by 0, so I'm going to skip 0. 0 would not be in the domain. Alright, so if I plug in negative 2, I'd get negative 1/2, and then it would look like this. Alright, so this graph, these rational functions have asymptotes, just like our exponential and our logarithm graphs. But the thing that makes these different is they have both horizontal and vertical asymptotes. So in this parent function, we'll have a vertical asymptote at 0 and a horizontal asymptote at 0. Okay, so our graph cannot cross those. Every once in a while, but let's not worry about it, it can cross the horizontal, but it'll never cross the vertical. But don't worry about that right now. We'll talk about that again in college algebra. Alright, so let's plot these points. And I'll show you what's going to happen with these kind of graphs, these rational functions. Alright, negative 2, negative 1/2, negative 1, negative 1. And what happens is this is going to be a piece of our graph that's going to follow the asymptotes. It's not going to cross. And then let's plot 1, 1, and 2, 1/2. And this is going to be another piece following these asymptotes. And these two pieces are called branches. Excuse me. Alright, and the graph itself is called a hyperbola. So the graph of a rational function is called a hyperbola. Just like, you know, a quadratic function, the graph is called a parabola. have to do domain and range. And the domain is all real numbers except for 1. Since we can't divide by 0, x cannot equal 0. And you'll notice that the y values never get to 0 either. So all reals, but y cannot be 0. Okay, when it has this basic form, where you have a number on top and just x on the bottom, in this basic form, you're going to have the same asymptotes and the same domain and range. Okay, so let's look at another example of one that looks like this. They want me to graph y equals 4 over x and state the domain and range. Okay, so you'll notice that it looks very similar. It's got a number on top and an x on the bottom. So I know that it's going to have the same asymptotes at 0. So I always like to put in my asymptotes first. So here's my vertical at x equals 0, and here's my horizontal at y equals 0. Alright, so let's make a simple xy table again. We can't use 0 because we'd still be dividing by 0. So if I plug in -2, I would get out -2. Plug in -1, I'd get out 4. Okay, so again, we're going to have the branches. Okay, so -2, -2, -1, -4. And then just go ahead and follow those asymptotes. 1, 4, and 2, 2. And follow those asymptotes. So again, the domain and range are going to be the same. All reals, but x can't be 0. Range. All reals, but y can't be 0. Okay, now, of course there's going to be other forms that your graph could take. So, let's do another one. A rational graph can also look like this, where you have that number on top, but you have x subtracting or adding something, and then subtracting or adding something to the side. When it looks like this, your asymptotes are pretty easy to find. I use VA to represent vertical asymptote. It would be x equals h, so this number right here, and then HA as a shortcut for horizontal asymptote would be y equals k, whatever number is right there. And then when you get ready, you're going to pick x values. You need to make an xy table, so pick x values to the right and to the left of the vertical asymptote. It's kind of your dividing line, okay? And so then you're going to plot those points and draw your branches. And you'll still need to state the domain and range. Alright, so let's do an example of one that looks like this. We're going to graph y equals -6, x plus 3 plus 2. Alright, so let's find our vertical asymptote. And since this is plus, you're going to change the sign to get x equals -3. Okay, because it would have had to be minus -3 to get that plus sign there. And your horizontal asymptote is always going to be that number. You don't need to change the sign. Okay, so let's go ahead and make our graph and put in those asymptotes, because that will really help you to visualize what's happening here. Alright, so our vertical asymptote is at -3. Whoops, I got off a little bit there. Going through -3. And our horizontal asymptote is going through +2 on the y. Okay, so we're going to follow these asymptotes. So we're going to make our XY table now. And remember, you're going to pick points to the right of this vertical asymptote and to the left to plug in on your XY table. So I'm going to do -4 and -5, and that would be over here, -4 and -5. And then I'm going to pick -2 and -1 to the right of the asymptote. Okay, so when I plug it in for x, I don't need that right now. I do -6. I'm plugging in -4. So, whoops, sorry. -4 plus 3, and then I'm going to add 2 to that. So that'd be -6. -4 plus 3 is -1 plus 2. So +6 plus 2 would give me 8. Okay. Alright, so that's how you're going to plug it in. I'm just going to fill in the rest of it, but I would do the same on all of those. Okay. Alright, so -4, 8. Alright, -4, 8 is right here. And then -5, 5. Right here. Okay, and then it's just going to follow these asymptotes. So remember to not cross the asymptotes. Alright, and then -2, -4. And -1, -1. So again, it's going to make a branch following those asymptotes. Alright, so then we plotted the points and we drew our branches, and we need to do domain and range. So all reals, but the x values are never going, you could never use the -3 because that'll make a 0 in the denominator, so x can't be -3 in the range. All reals, but y can never equal 2 because that's where the other asymptote is. Okay, that's the end for part 1 of 8.1.